whatever part of the world she's been coming from. I met Candace, gosh, almost at the beginning, I think, of the Open Learning Initiative, 2002, which I think was one of the principal beneficiaries of the Hewlett and Mellon Foundation leadership around funding open education resources. And I think, along with very few other places on the planet, they have brought together a phenomenal team that Candace has led that brings faculty together with who are teaching the courses together with learning scientists, cognitive scientists, who understand how to think about reasoning and modeling the knowledge in a discipline, and have really focused on a program of continuous improvement for the online courses that are provided. And Candace, I think, is going to share with us today some of that work. She has also served on the technical working group for the National Education Technology Plan, which I enjoyed working with her on, and on a President's Committee of Council of Advisors, the Science and Technology group with, in fact, Dan Schwartz, in writing an Engage and Inspire report on STEM higher education and how it might be reformed and improved. So Candace, welcome to Stanford.
Thank you, Roy. I've got my own.
You got your own.
Okay, thank you. So I was here last May doing a talk. I'm just curious who in the room was at that talk, so I know prior knowledge. Oh, we've got a nice diversity here. Okay, so I'm going to do, for those of you who saw it in May, you're going to see some of the same stuff again, because so we can get a level playing field. And I'm going to hopefully talk not for a long time, which I'll try and control myself, because what I really want to do is have conversation. Because as Roy pointed out and as Mitchell pointed out, there is a lot going on in this space, and I very much want to hear your perspectives and what you think the big challenges are that are before us. So what I thought I'd start off with is just doing an overview of the Open Learning Initiative, which is the project I direct at Carnegie Mellon. So I'll start off by saying back last December, President Obama called together 10 university presidents and chancellors to address this challenge that's facing higher education of cost and attainment. And 9 of the presidents and chancellors were public universities. There was one president from a private research university that was invited, my president, Jerry Cohen, and explicitly told the reason he was invited was because of the work of OLI. And so just to say that the project that we're doing has gained a lot of national attention, but the whole question of how you balance cost and attainment is a big question that's confronting higher education, not so much at Stanford, but in a lot, and not so much at Carnegie Mellon, but in a lot of the rest of higher education. So one of the things that people are doing now is doing a lot of recorded lectures as was kind of the first step of trying to disseminate out offering open access to educational experiences. And we when we did OLI, we thought about, we didn't just record a bunch of lectures and make them available, because of this idea that really where students are learning is not by sitting and listening passively to a lecture, but rather by engaging in attempting to do something. And then having their attempts be getting feedback and support to improve their performance and improve their learning. So I'll say, what is the Open Learning Initiative? Well, in a nutshell, it is scientifically based, open online courses that are designed to improve both quality and productivity in higher education. Now, when I'm talking about science, I'm not talking about that they're all science courses, although most of them are, because the faculty at Carnegie Mellon who were interested in participating in the project at the beginning were mostly from computer science, chemistry, biology, statistics, and so on. The science I'm talking about is a science that is near and dear to the hearts of people in this room, the science of learning. And I don't have to explain to this group what that science is. I usually do. But what we do is, as Roy pointed out, is we bring together teams to develop these courses. We don't have individual faculty. It's not that an individual faculty member comes to us and says, I want to put my intro statistics course online. Help me do it. It's a completely different idea where we say we want to develop an introductory statistics course. and we bring together a team that include multiple disciplinary faculty, multiple statistics faculty, along with the learning researchers, along with the software engineers and the human-computer interaction experts. And we bring that team together to think about how do we use the affordances of the technology and what we know about learning to design a learning experience that would actually support students to achieve whatever the desired outcomes are. So we end up designing all kinds of learning activities, and I thought I'd give you an example of one. This is out of our engineering statics course, and I picked this one because I thought there would be some engineers in the room. Are there engineers here? Okay, so I'm talking to you. No, so this is a particular, in the engineering statics course, one of the skills we want students to be able to do is to be able to sum concurrent forces. So they've gone through some kind of instructional experience, and then they are at this place in the course, which occur very frequently in an OLI course called Did I Get This?, where they have a quick opportunity to try and see, are they tracking on what they're supposed to be tracking on? So we give them a simple problem. We give them these 3 forces, and we ask them the question, what's the magnitude of the sum and what's the direction of the sum? So the student can just go ahead and type in the answer. They get immediate feedback, and if they're not sure what to do, they can ask for a hint. And the hint first reminds them that the purpose of this activity is for them to assess themselves, so they should kind of try maybe some more, but if they really don't know what to do, they can ask for some support. So the student asks for some support, and the system says, remember, the first step is to resolve each of the forces into its components. Can you do that first step? And if the student can't do that, they can ask for a hint. And then there's a particular hint structure that we follow. The first is to basically give the student sort of the conceptual framework of how they should be thinking about the problem. Then give them the specific procedural hint clue. And then the bottom-out hint is what we call, the bottom-out hint is basically the answer. And so what we're trying to do is support students at any point along the way to be able to essentially synthesize and apply the knowledge they've learned to solve this particular problem. So we give them the bottom-out hint. They can answer that and continue moving. They finish the first part of the step, and it says, great that you got here. Now can you answer the question? If the student can answer the question, they can go ahead and do that. If not, they can continue to get support. So I've sort of fast-forwarded through, and so the student has finished the problem, but they've needed a lot of support and feedback and scaffolding to get there. So the system says, great that you were able to do this, but you might want to try again. And so click here, and a new problem is generated. All the hints and feedback change to give them targeted, context-specific feedback on each of the sub-steps again. So the idea here is to give students essentially 24/7 support in building fluency in that particular procedure. And this is based on this work that I'm sure you've heard about that Carnegie Mellon's been doing for years in the area of cognitive tutors. And that's pieces of software that are intended to act like a good human tutor, essentially giving the student support when they ask for it, giving the student feedback when they need it, and when the student is just moving along to just kind of hang back and not do anything. But, as I'm sure you're all thinking, higher education is more than just building procedural fluency. There are many other things that we want students to be able to develop than just how to sum force vectors. For example, we want them to be able, when confronted with some novel situation, to be able to bring to bear the things that they're learning to sort of take different perspectives and take approaches to addressing whatever it is the task they're confronting. So we do all kinds of different design ideas. This is one of them when we're teaching students chemistry, stoichiometry. Rather than just saying, here's stoichiometry, learn it, we situate it into a real-world problem. And this, in this case, is the arsenic contamination of the water supply in Bangladesh. So the students get a really short little video saying this is a real-world problem. Then they get put in the role of chemist, and they get given a little task. And the first task is they get a well water sample out of a well in Bangladesh, and they're asked, is this water safe to drink? Now, they can look at this. Do we have chemists in the room? No chemists. OK. Then I won't go into great detail here. But they can look at the solution viewer here, and they are told that the World Health Organization says 10 micrograms per liter is safe drinking water. But when they look at the analyzer, no place here can they see how many micrograms per liter of arsenic is in that water. What they know is how many moles of arsenic is in that water. So in order to even do the first task, they have to be able to do the conversion of molarity to micrograms per liter. Again, they can type in their answers. It'll trap for common things, give them hints and feedback. If they're totally just floundering and don't have a clue what to do, then they get put into sort of a just-in-time learning experience that walks them through how to do the dimensional analysis. So the point here is that what we're doing is essentially using feedback to support the student as they are learning. And you can see that in the examples that I've given you. What you can't see that's also happening is as the students are working in that environment, every move they make, we're capturing that. And we're using that data not just to give feedback to the learner, but also give feedback to other actors in the educational system. And one of those is the instructor. So this allows us to do a different kind of flipped classroom. So rather, say if you teach Mondays and Wednesdays at 10 a.m., well, probably noon. Let's say you teach Mondays and Wednesdays at noon. And on Wednesday, you say to your students, rather than read through Chapter 10 of the textbook, work through Module 3 of the OLI course. And as you're working through the module, finish it before 10 o'clock Sunday night, because we're going to meet at noon on Monday. The students working through the course, as they're working, they're getting all the hints and feedback, but the system's also collecting all of their interactions. And it's driving an underlying knowledge model so that we can make predictions about what the student's knowledge state is against the learning outcomes. So this is an actual screenshot. This is out of our statistics course, which is used at multiple institutions. This is a screenshot out of a course at Santa Ana College. So the first thing is, this is the instructor dashboard. So the instructor can look at, these are the learning outcomes for this particular module. And they can get a quick snapshot of what their class is like. So this bar shows you essentially the proportion of your class that's in green. If green means that those students, if you were to give them a task which assessed their ability to relate measures of center and spread in the shape of a distribution and choose the appropriate measure and context, that those students we would predict would be able to do that task. The students in orange, we'd say they're kind of moderate. The students in red are doing the work, but they're really struggling. The students in gray, anybody have a guess what gray means? Yeah, they haven't done enough work in the system for us to give you any kind of clue about what their knowledge state might be. So if you only have a little bit of time before lecture, you could look at this and make decisions about where you want to focus or not. If you've got a little more time, you can drill down. And one way you can drill down is to expand that bar and see, okay, each dot in this bar is a student. You could also drill down to see who are those students that are in orange. Now, I put a bar over it because, as I said, I took these screen captures out of a real running course. As an instructor, the names would not be covered. But you can see who are those students and how many activities they've attempted that are feeding that particular outcome. You could also click in a little bit more by looking at each individual student. So you can look at each student and say, in that module, here, this is the student that was in orange. These are the activities that are available that are feeding that outcome that they've attempted or not attempted. And then you can drill down further if you want to look specifically at their performance.
Does that suggest there's a relationship between drinking habits and integrity there?
Oh, this one? Oh, this is one of the labs where where they're doing an analysis to look at whether there's a relationship between drinking habits and integrity of college students.
Operationalization for integrity there?
Oh. That one actually is about would they report cheating if they observed it in their class. Then you can also, as I said, drill down into any particular question and see this is more like what you get out of a traditional LMS, where you can see on any particular question that's tied to that outcome, how did the students perform. And the kinds of activities that we give students, again, when we're teaching them, say, compute the median, we don't just say, here's the median, here are 10 array of numbers, compute the median 10 times, and then we'll know whether you compute the median. What we do is we embed that activity, that task of computing the median, into much richer, larger tasks. And every time the student comes across an activity where computing the median is a sub-skill, we can probe, can they do it? And can they do it in a couple ways? Can they identify that computing the median is the thing that they should do there? Can they then compute the median? Can they then interpret the results that they got to make progress on the task that they're doing? They're also open-ended. Many of the tasks have open-ended questions, which, again, we aggregate for the faculty member as well. And this gets me to really what I think the affordances are of this technology that we're all experimenting with. When you ask most people, what are the affordances of online? Usually they'll tell you one of three things. This one over here is you can do really cool stuff online. You know, you can do simulations, you can do games, you can show students things at microscopic levels that you can't show them in the real world. You can have students construct bridges and collapse them and not kill anybody. You know, so that you can create these really robust experiences in the online environment that you can't do in the carbon-based classroom. And that's a great power. The other thing that this is the most common thing people talk about, access and convenience. That given these online environments, students can learn any place, anytime, anywhere. And the third one is connectivity, that these environments allow us to connect students to each other, to expertise, to the world. And those three powers are really great, but as I think we're learning, that's not the biggest power of these technologies. The biggest power of these technologies is actually what Google has figured out. It's what Netflix has figured out, and Amazon. The biggest power of these technologies is not just that you can push stuff out, but that they're great big data collectors. And you can push the information out just far enough so that you have the learner interact with it and you can learn a lot about the learner. Now, when Amazon, and that's why we call it our killer app, now when Amazon or Google is doing that, they're doing it because they're trying to understand us better as consumers, both individual consumers, but consumers as a group. When we're doing it, we're trying to understand us better as learners, both the individual learner, so that we can give the learner themselves and the faculty member better guidance about how to support that learner, but also learners as a group. As we're trying to understand how do people learn, then having these vast ability to collect data in controlled ways to both refine our hypotheses about learning happens, we can really make great progress in how we design educational environments. So the feedback loops, I already talked about the student, and I talked about the instructor. The other one, the other feedback loop, the same data pool we give to the course design teams. So the student gets the feedback based on their own data. The instructor gets the feedback just on their class. The course design team gets the feedback, the data from all of the courses that are running across the country in their domain. So if you're working on a statistics development team, you're getting all of that data from all of the classes that are using statistics. And as I said, then that feeds back into the development process for continuous improvement. So we start off planning the course. We use that design team to do the first iteration of the course. Then we get it out there and have it be used. And the faculty that are using and evaluating the course feed back into the development process. So we set up this cycle of planning and refinement of the course. It's ongoing continuous improvement of the course. And the data representation for the course design teams look different than the data representations for the faculty or for the student. So for the course design team, we might look at, and I should say the sister project to my project is the Pittsburgh Science of Learning Center, which is an NSF-funded research center, just as I know you have an NSF-funded center as well. And they use the OLI courses as their research platform. They also then spend a lot of their NSF funding developing analysis tools, which we can use to then analyze our course data. So this is a learning curve analysis. So what this is the y-axis. Now, when I was showing you the engineering statics example, did it bother anybody thinking, oh, my student's just going to go hint, 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 type in the answer. Hint, 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 type in the answer. Probably not at Stanford. But when I do this at other colleges, they're like, yeah, my students are totally going to do that. But the difference is we know. So all that, every time they ask for a hint, every time they get feedback, that contributes to what we call their error rate or their assistance score. It's the number of hints and feedback they get when they're confronted with that knowledge component. The x-axis is the number of opportunities they had to demonstrate that knowledge. So the reason we like this learning curve is because it shows us that when they were first confronted with that knowledge component, they needed a lot of hints and feedback. But over time, with practice, they needed less. So this is a curve that we would say learning is happening. Now, they don't always look like this. Sometimes they start up here, and they kind of fluctuate up there across the top. What would that tell you? You know, in what way? Pardon? Oh, yeah. So they're doing what we asked them to do. They're practicing, but it's not facilitating their learning. Sometimes, I mean, these are all clues that we need a better course. Sometimes it starts down here and stays low. What would that tell you? Yeah, we're wasting their time. We're giving them lots of practice in stuff they don't really need practice in. Sometimes, and these are the ones that are fun, it can kind of slope down like this, hit an inflection point, and then shoot up. Any guesses on that? Yeah, sometimes, well, if we're looking at a student performance, often what that tells us is we misspecified the knowledge model. That something that the expert thought was a single knowledge component, actually we've introduced something new that added a level of complexity or some new knowledge, and the student needed the support for that.
Oh, it had been clumped in the instructional module in a sense, and the response from the student indicated that there were multiple components.
So let's say this is a knowledge model of compute the median, for example. And they're nicely sloping down where every time they come across a task where they're computing the median, they can do it. But then you give them a new task, which the domain expert has labeled as the skill involved is compute the median. But it's not just compute the median. It's also distinguish the median from the mean. And so the student needed hints because they were looking at it and they didn't identify that what I needed to do right there is compute the median. Or they got bored. Yeah. Yeah, and they do, one of the things that we do look at is gaming behavior. And I don't mean gaming like video gaming. I mean like gaming the system behavior. And there's all kinds of research looking at productive gaming and unproductive gaming and how you can identify when students are gaming productively and not, and then interventions you can take. Okay, so the idea here is that, better insights, we get better courses. And in the past, we've always done this very careful cognitive task analysis to be able to understand what the components are and how you need to build the tasks to support students to achieve them. But that's very labor intensive. People here do cognitive task analysis? Oh, it's very labor intensive, but you get really good results from it. But the new opportunity using the data is we can start to automate the process. So looking at these learning curves, we can start to look at where do we need to focus the attention in doing the analysis, as opposed to having it do it all completely labor intensive. And so I'm actually going to stop there and see if there are any questions or comments. Yeah?
Daniel, can you stand up and introduce yourself? I'm going to ask people to do that initially, because part of what we're trying to do is make new connections here and let Candace know.
Hi, I'm Daniel Green. I'm a third-year doctoral student here in Learning Sciences and Technology Design. And I was wondering if you could say more about that last slide about automating cognitive task analysis and how you, especially how you distinguish between different knowledge components or sub-skills before having done any analysis. It's sort of how do you know what you're looking for when you make that, when you undergo that analysis?
Okay. So I'll try and make a brief answer to that question. So when we first design a course, we design what we call the naive model. That means a model that has not been yet empirically validated. And that is we have the faculty domain experts work with us to look at all the activities we've designed and make a first-pass attempt at essentially tagging the learning outcomes and the skills to the activities. And so that's just, so we call that the naive model because we probably shouldn't call it the naive model. I didn't know what else to call it. But it's based on the domain expert's belief about what knowledge is connected to what. And so then when we run the courses, we are collecting all of that interaction level data, and it's tagged with those skills and learning outcomes. And then we put it into the data analysis tools at the Pittsburgh Science of Learning Center to look at learning curves and fit. And then when we see things like those inflection points, then we look at it again and say, what could be going on there? And then we say, oh, well, that's really not just compute the median, it's distinguish the mean from the median. So let's unpack that. And then we can extract the data, again, re-tag it, and then reanalyze it. So it can be an iterative process. There are researchers at Carnegie Mellon that are trying to create essentially automated wizards that will run over the data to suggest different knowledge models from the data. And they did just do a recent experiment where they had a cognitive scientist take 2 modules out of our engineering statics course and suggest the knowledge model, and then gave it to the wizard to suggest the knowledge model. And the wizard came up with 3 potential models, one of which was really close to the model that the human did. I'm not trying to for all the cognitive scientists in the room, I'm not trying to replace, just like I'm not trying to replace faculty, I'm not trying to replace cognitive scientists. I'm trying to think about how can we use the tools to support the work better.
2 questions, Candace, and then I'll hand this over to somebody else. Knowledge components. Have you worked with faculty outside the sciences in identifying knowledge components for historical reasoning or mathematics teaching or any one of a number of things there? And secondly, what size of classes do you need to make meaningful learning curves? I think a lot of these are fairly sizable classes, right? So.
Okay, so the first question is, I know everyone looks at this and says, okay, I can see how this works for chemistry and statistics, but it will not work in history or English or anything like that. And I agree that the tutoring methodology may not be the best approach for teaching those things, but the idea behind OLI, I always just show the tutor as an example because that's where Carnegie Mellon's historical expertise has been. But the idea is that you get with the faculty domain experts, the learning researchers, and you say what's really critical for students to be able to do and know to get out of the learning experience. And then what kinds of technologies can we bring to bear to design activities that would support students to achieve those outcomes and also to be able to probe what's happening in the environment. I mean, I think some of the work that you do here at Stanford would be really interesting to think about. How can we look at cues in the data stream that's telling us what's going on? Like, for example, if we're looking at in the online environment and we're curious about what are the cues in that environment that are either supporting or the student to experience stereotype threat or diminishing that possibility, then how do we analyze whether that is happening or not happening, and how do we shift the cues in the online environment based on prior research to explore that further? In terms of your second question, how big of a class do you need? Well, the data that we're collecting for the learning research purposes isn't across a single class. It's across, last semester we had 60 classes in varying Carnegie classification institutions using the OLI statistics course. And so we can basically slice that data we can slice it by institution type, we can slice it by all kinds of different variables and sample out of it in different ways. And then the exact, it's not an exact number that you need. You need exactly 100 to be able to do an analysis. It really depends a lot on the domain and the grain size of the knowledge component too.
More questions?
Hi, my name is Don Barr. Excuse me. I'm on faculty in the School of Medicine and also courtesy in the School of Education. In my own area of research is undergraduate science and particularly pre-medical education. I would suggest that this moving to the online learning is revolutionary in and of itself, but there's a second aspect potentially that is revolutionary, which is the facility of developing these courses across traditional disciplinary boundaries.
Absolutely.
And as I remember this guy Galileo saying, when you bump up if you go a little bit too far sometimes with this revolutionary thinking, sometimes those in positions of authority or status don't agree. It sounds as though when you're developing it at Carnegie Mellon, it all went very smoothly in developing these teams and all that stuff. What about this idea that there are certain institutional boundaries that when you bump up against, it's tough to do this type of learning?
Yeah, so first let me disabuse you of that first postulate. It's not like I went around to faculty and said, we're going to do this cool thing. You want to do it? Oh, yeah, great. And everybody plays well together. It is, that's part of the learning experience, actually, is how you get faculty and people with all kinds of different expertise to work together towards a shared and meaningful goal, respecting the diversity of expertise in the room. That I could do a whole talk just on that, which I won't. But also you have faculty who have varying different ideas about what is, and students who have very different ideas about what is learning and what is teaching. And so framing it around essentially a community-based research activity is a way that I think facilitated that. So it was not the case at any point in time that I went to any faculty and said, let me help you figure out how to teach, because I know you don't. I know all the learning research. You don't. Let me tell you how to teach. Non-starter. But what is an interesting question is the way that we're currently teaching, where I'm standing in front of you, and as I'm teaching you, I'm looking at your faces. I'm getting cues all the time about what you're learning, what you're not learning, what's resonating, what's not, and I can adjust what I'm doing based on that feedback that I'm getting instantly from you. When you're creating these online environments, that feedback loop is broken. So I never say to a faculty member, I don't doubt that you don't have that robust feedback loop going, that you're adapting and everything in your classroom. But what we have to anticipate is that look of confusion, that student being lost when you can't see it. And then what would we do to support that student at that moment? And in order to be able to do that, that's a skill that, you don't have. And that we can bring this variety of experts together, people who know about how people learn, people who know the affordances of the technology, and then your domain expertise and your experience as a teacher, and really think about how do we create an environment that will support that learner when you're not getting that immediate feedback loop. That's the first thing. The other thing is the faculty who really enjoy working on OLI projects are fundamentally researchers. A couple things. They love their domain, and they think that, chemistry is just beautiful. And they're completely astounded when their students don't share the awe of how beautiful that domain is. They're astounded about that, and they're also astounded that equilibrium, it's such a fundamental concept. And it's so clear. I explain it very clearly to my students, and they don't get it. What's wrong? Why don't they get it? And they get it enough to pass the test, but they don't get it the way I want them to get it. And that becomes an interesting research question. So then you pair that faculty member or that group of faculty with the folks who really are understanding learning and the software engineers, and you think about, okay, equilibrium. It's an important concept. It's a concept that you don't feel like your freshmen get the way you want them to get it. How can we unpack that and create a learning experience that might support your freshmen to get that? And that process can take some time. And then we collect the data to say, did we do it? And the faculty really get to be like kids in a candy store waiting for the data to come back. Because we have this I think of every OLI course as a hypothesis. Based on what we think we know about how people learn, based on what we're trying to get students to get in this domain, based on what we can do with the technology, it's our hypothesis that students engaging with this experience will move them from here to here. Now let's try it and see if it worked. and then see where it's not working so we can focus our attention on that to refine it. And we are getting, I think on one of my slides, we do get significant results in improvement in learning outcome, both the accelerated learning studies that we did, as well as just like on things like on equilibrium. Dramatic improvement in students really getting equilibrium the way the chemistry faculty want them to. Yeah.
So we had started to talk about teaching evaluations, and Michelle Marinkovich from the Center for Teaching and Learning. When we ran out of time. So I just wanted to pursue that a little bit more, especially in light of what you just said about the student learning outcomes, that they're stronger. So are these courses at Carnegie Mellon covered by the regular student evaluation of teaching system? And do they end up bringing faculty better evaluations, especially after the courses have been taught for a while, they've been reiterated and have, in a sense, settled down successfully? Or, as we also started to talk about, sometimes when a class is dramatically changed, and particularly when the responsibilities of the students for their learning are changed, that can create a difficult teaching evaluation situation for the faculty member. So I guess I would just welcome your comments about what
sure.
you've
We talked about
seen.
this before. That's how. So because what is the case is that, like in our engineering statics course, when we first. So first, let me answer your first questions. All of the OLI courses are taught at Carnegie Mellon in hybrid mode. They're not. We do not have the case where we just send students to do it completely online and then give them a grade. So that's not the way they're used at Carnegie Mellon. There are some institutions that use them as completely online courses. But in Carnegie Mellon, we use them where the students still come to class and meet with a faculty member and use the OLI course outside of class. Now, sometimes that means that the number of times they come to class is reduced or the length of the class is reduced. But it's always in hybrid mode, with the exception of, there are two exceptions to that. One of them is graduate students. When they are accepted into certain master's programs, the programs got tired of teaching students introductory statistics again at the master's level. So they just point the students to the OLI statistics course and say, you are accountable for this knowledge on day one. We're not going to reteach it to you, so make sure you come prepared. And then the other course is a course that's required of all students at Carnegie Mellon, but it's not an academic course. It's called Computing at Carnegie Mellon, and it's basically information literacy, safe computing, all that kind of nuts and bolts stuff. And the students can take that before they come their freshman year. But I bet a lot of them still take it once they get there. In any case, your question about faculty course evaluations. So in some cases, they go up, and in some cases, they go down. In the engineering statics course, when we first did OLI with engineering statics, the faculty member who got really good course evaluations in general, his faculty course evaluations went down. And it upset him, understandably. And there are a couple, and you unpack that, there are a couple things that were going on. One of them was he was teaching still a 200-person lecture course. So he would set up the students, they'd go off, they'd do the work, he'd look at the instructor dashboard, he'd see the variability in where the students were, but the classroom he was teaching in was, fixed chairs, auditorium style. So he had no idea what to do. It's like, okay, I know a lot of you know this, I know a lot of you know that, I can't really do anything different. And so the facility of the course wasn't actually allowing him to change his teaching practice. The other thing was he ended up, in some ways, the students felt like he was shirking his teaching responsibilities, because their idea was they're coming to Carnegie Mellon, they're paying big tuition, just like they pay here at Stanford, and they want to come to a classroom and have the faculty member tell them. And instead, they were being asked to go do all this work before they came to class, where they felt like the faculty member was basically telling them they had to teach themselves. So those were the two big disconnects. Now, he has subsequently figured out different ways of using the environment, so his faculty course evaluations are going back up again. But there is, and what we find is it's really good often to tell the students up front that this is going to be a different experience, and what their role is, what the faculty member's role is, and how that shift, may be experienced, and to keep that conversation going throughout the class. In the statistics course, when we did the first accelerated course, and this was where using the OLI statistics course, the students completed the 15-week course in 8 weeks instead of 15 weeks. And they met with the faculty member twice a week instead of 4 times a week. And the faculty member who was the faculty member for the accelerated course was a real skeptic before the course because he's a high relationship, high touch kind of faculty member. And his concern was only having the students for 8 weeks, twice a week, that he wasn't going to get that connection. At the end of it, he said it was the best experience he'd had in teaching for 15 years of teaching statistics. And the reason for it, when you probe it, wasn't because any magic. It was about, he said, well, what happens is when I send my students off, usually, they do stuff, and they come to class, and I spend the first part of class really trying to see what it is they're getting and not getting and where to target what I'm talking about. For the first time, the students came to class, and they already knew what they knew and what they didn't know. And I knew what they knew and what they didn't know. But probably the most important thing was that they knew that I knew what they knew and what they didn't know. And so we spent that 50 minutes in incredibly kind of aligned position of this is where you are, this is where we're going. And it made it a much more connected experience for him.
Yes, here I am. Hi, good afternoon. I'm Prudence Carter. A question about variable learning styles. And how do you account for the reality that there are variable learning styles among students and even students with disabilities at the university? Does the OLI process kind of assume that there is a universal or homogenized way that you can teach, that all kids can learn, or do you take into account these multiple learning styles, and if so, how?
Yeah, so we have just recently partnered with a group called CAST, which is up in Massachusetts, and they're the big champions of universal design for learning, in recognition that students, may express themselves and demonstrate their knowledge in different ways, and also have different, hearing, seeing abilities. So we're moving more in that direction, but our courses are not completely accessible in that way yet. Now, in terms of learning styles, I think that's a big research question. Are there learning styles that are a fixed attribute of the learner? Or how much is what we think of as an attribute of the learner actually a complex interaction between the learner, their current knowledge state, the demands of the domain, the context in which they're learning? And I think one of my real hopes for these environments is up until this point, learning is really complex, as you all know. And it's so complex that I think we've attempted to try and manage the complexity in some ways so that we can deliver it at scale. And one of the ways we try and manage the complexity is to categorize and say, oh, okay, you're a visual learner, you're an auditory learner, you're a kinesthetic learner, and if you're mostly, that's how you learn best, then I can sort of think, okay, then I can have a category that gives me some insight into what to do for you at any given point in time. And so I think that those forms of categorization were really well intended, but I don't know to what extent they're really empirically validated. That the categories that we think make distinctions among learners, we're going to find there are a lot more complex variables that interact. And the beauty of an information technology is it can help us really manage that complexity in much more robust ways. And that gets to this. I was going to do this little thing about, I think this sort of feeds a little bit into it, is a lot of folks here from the ed school, right? So you're familiar with lots of educational and learning theory. And oftentimes, it gets boiled down into dichotomies. People get into arguments about design, we debate about it that way. So this is a paper by one of my colleagues, Ken Kadinger, just wrote a paper about this, which I can send you. So people get into these arguments. These sound familiar? Students need more basic practice, more basics. No, they need more challenging activities to facilitate their understanding. And there are lots of books that kind of help give us guidance on that. But actually, it's more complex than that. So if you say that students need more basic help, okay, then how are you going to help them? Are you going to give them more focused practice or more distributed practice? Or are you going to gradually widen the practice opportunity? Once you make one of those decisions, then you have to decide, okay, if I'm going to give them focused practice, what am I going to have them do? Am I going to have them study worked examples? Am I going to have them engage in problem solving? Or am I going to do a 50-50 blend, and how am I going to interleave them? Once you make that decision, and you have to make that decision irrespective of which of those you chose, and then you have to decide, okay, if I'm going to have them study worked examples, then should those examples be concrete, abstract, or a mix? And so you get the point. It starts to, that at any given point, if you're trying to create a learning experience that's individualized for that learner, the number of decisions you have to make is huge. The other thing Ken says that I love is he says, learning theories are like toothbrushes. Everybody has one. Nobody wants to use anybody else's. So this is my last slide. This is my strategy for educational improvement. It is about the reintegration of practice and research. That in order to design really good educational technology, we need much better understanding of how people learn. We need better learning theory. But we can use the learning theory we have to inform the technology design now. And then we use that technology to collect the data. Because to get better theory, we need a lot more data about a lot more students in a lot more contexts. So we use the theory to design the technology. We use the technology to collect the data. We use the data to refine the theory. And we set up this virtuous cycle. And that's what I think is really the way we're going to use technology effectively to improve higher education.
I think it's going to go Dan, Petra, and then David Laveray.
Hey, Candace. This is Dan Schwartz.
Yeah.
So this is a platform question. This is not a back-end data analysis question.
Okay.
So different platforms implement different people's sort of visions of learning. OLI is no different. It's a particular subset of learning principles. So 10 years from now, what is your dream platform that we should be driving towards? What are some of the bells and whistles it'll have?
Okay. I like that question, actually. Thanks.
That was underhand.
You were what? You were underhand.
It was an underhand.
Oh, come on. You were supposed to do that. I went to the game last night, by the way. Anyway, so OLI to date has been very driven by the research proclivities of Carnegie Mellon, which are very strongly in the cognitive, very strongly in the AI domain. So as you probably noticed, a lot of the learning experiences we create are intended to both support cognitive processes as well as probe, can we get insight into what the cognitive processes are that the students are engaging. I don't think I have to tell anybody in this room that learning, even more than just those little dichotomies I was showing, is much more complex than just what's going on cognitively. There are all kinds of things that, which people hear research, that affect the learning experience. And what I would imagine is this environment is very much structured individual learner to computer, which is one interaction we can capture. But as we know, there are much greater interactions now of learners to learners, learners to other resources, to people, et cetera. So my dream platform would actually be a platform that was constructed with an interesting, well thought out, at least ingoing synthesis of those different aspects of what we, at this point in time, believe are critical to support learning. And then instrumented in such a way that we could collect the data to refine those hypotheses or discover new ones. Does that answer your question?
Okay. Hi, my name is Petra Dirkestran. I'm a comparative literature lecturer here at Stanford, and I'm actually going to open the can of the humanities again, if you don't mind. I really, your answer just now was just really exciting, because one of those things in the humanities, I think, of course, assessment is a huge problem for us, because, it just works differently than the sciences, as we all know. And one of the things I wanted to ask about, I really like this idea of feedback, and that the specifically that the instructor is only part of the feedback cycle. So, kind of like just one factor. And I was going to ask, and you almost have answered that, what about peer learners? Because one of the things about the humanities, I think, could be a wonderful thing for the future is that, kind of harvest the power that, students can learn from other students, especially in the humanities courses that we teach. The writing, when it becomes public, improves, as people like Andrea Lunsford here at Stanford have shown with their research, for example. And so, is there any way that we can, not just for the humanities, but, take the peer learning and the public comments on things like public blogs, for example, into account as a feedback cycle?
Yes.
How?
So yes, and I think one of the things that we need to look at is peer learning. That there's lots of what people call peer learning. There's lots of stuff going on. And so I think it would be good to maybe unpack that a bit and say, what are the things about peer learning that we think facilitate learning? And then probe, how do they and how don't they? By constructing, this is what I keep saying, it's the reintegration of research and practice. If we have a particular hypothesis about something that we believe, either because we've demonstrated in laboratory studies or because we just believe it from our observation, that something supports learning, then this is where I think, back to your question about getting multiple faculty and with people with different expertise working together, this is where we need each other. Because the learning researchers are often off over here studying these really interesting aspects of human learning. And then faculty or others are over here trying to figure out how to help their students learn something in the domain that's important to them. And bringing those two groups together in a shared research goal is really where I think education research needs to happen. Just recently, there was we have invited speakers come to Carnegie Mellon as well. And there was an invited speaker who was coming, who was a learning researcher, who was doing a talk about analyzing some aspect of instance of torque in engineering. And so I saw that I get the notice of those speakers coming, so I sent it to my engineering faculty and said, you might find this interesting. And so he went to the talk, and then I spoke with him afterwards, and I said, what'd you think of the talk? He said, it was interesting from a learning science perspective, but it was really a missed opportunity. I said, well, how? He said, well, they created this really clever instruction and experiment to try and understand the instance of torque. And that's kind of, for mechanical engineers, that's kind of uninteresting. Students get that like that. It's not one of the challenges in the domain. If they just shifted it a little bit and really focused on, stresses on trusses, and they could really get students to get that would have been good. And so here was a learning researcher discovering something in the basic science of learning, but if it had been shaped a little bit differently, could also have been making progress on real-world problems. And then you have all these faculty out there trying to design stuff to make progress and solve real-world problems, like how do we get students to learn math, but they're not shaping their interventions in a way that help us make progress on the fundamental questions about learning. And I think the real gold is in bringing those groups together to say, what are the real problems like equilibrium in chemistry? And then what do we know about learning, and how can we construct a learning experience that allows us to refine our understanding of how both those things happen? Which gets me a long way back to your question. So so we have these questions about peer learning, or we maybe don't. Maybe people think, oh, I know peer learning is good. But I think that what we need to do is structure the environment so that we can have students engage in the peer learning behavior and probe to what extent does it, doesn't it, how does it support learning. Yeah. Okay, follow away.
It was a softball, but you had a home run on a different question.
Okay.
I was wondering what sort of widgets you would put in. So like I've been looking at the different platforms that are going on around here.
Oh, yeah.
One has sort of video with it pauses and you do exercise.
Right.
and then the video starts.
Uh-huh.
Another one has this sort of students ask each other questions, and then at the bottom there's a big green banner that says the professor has only answered 12% of this class's questions.
Uh-huh.
That one's got it done. That's what sort of widgets can you imagine 10 years down the line that will go in here and, conceivably address learning theories as well? But I'm not even asking that question. I'm just asking what kind of widgets do we want 10 years from now?
Okay, so I think that that's not my question to answer. I actually think that's your question to answer, both for the folks that do learning research. Like, what are the theoretical models that you're working with that collecting some data, like large amounts of data from multiple students, would help you refine that theoretical perspective? Like, if you're thinking about, say, invention, what kind of, as preparation for future learning, what kind of widget would you want to have that would help you construct experiments that would allow you to refine your theory?
David and John.
I was asking Dan to answer that question.
I've already taken up on it.
Okay. We could maybe have one where it's a shoot-'em-up game for looking at variability. Oh, sorry. Go ahead.
Hi,
Did
David
you work with
Lappert.
I'm sorry. Oh, sorry.
Yes, in front of you. I wanted to go back to Roy's first question because I'm not sure you answered it, and that is about, I look at this and I'm saying, I see how it works in certain kinds of teaching settings and certain kinds of subject matters, but in certain kinds of knowledge outcomes you're trying to accomplish. And it particularly seems to work in situations where you have like a ladder of learning. You have to learn this in order to be able to do this, and then you need that in order to do another thing. You have to climb the ladder, and you can lead people through the steps. Seems to be working particularly in skills courses, particularly where there's an algorithm to be learned and there's a right answer to come up with. So what about in all these other kinds of domains where there is no ladder of learning, where you're making a lot of leaps, where you're doing conceptual analysis, where you're synthesizing, where you're constructing arguments, where you're supporting them, where you're training people in judgment, not in climbing the ladder? I don't know. I don't see it. I don't see what it does.
Okay, that's great. So, two things before I will answer your question, but two things. One of them is I actually don't see learning, even in these environments, as a ladder. And in fact, those learning dashboards that I was showing, they change constantly. So things that you're learning in Module 1, later on in Module 7, when you get there, the learning dashboard in Module 1 may shift because the system is probing your knowledge state on that concept at that point in time. I don't think of learning as a ladder. I think of learning as a web. And sometimes you're not going to get something, and then like if you're learning percentage, you might get percentage in this context, but then you get it in a new context and you don't get it. It's not that you don't get percentage. You're constantly refining your idea of it. So it may look like a ladder, but it's not a traditional mastery kind of thing like that. It's really a web. And people get things at different points in time with different interactions of different kinds of experiences. But that wasn't your question. Your question was, what about these more ill-structured domains where there isn't a right answer? I don't mean ill-structured. Ill-structured isn't derogatory. Sorry, ill-structured wasn't derogatory. Pardon? Differently structured. No, what I mean is, rigid. Okay, so how about this? More flexibly structured domains. But I would still submit that in English, and so what I always start with faculty with this question. After spending 15 weeks with you, what is it you wanted your students to get out of that? And that could be, I want them to be able to subforce vectors. It could be, I want them to be able to participate authentically in the discourse of the domain of history. Great. So what does that look like? And we can do all kinds of things to look at what does that look like. Because oftentimes the OLI process is as much about unpacking what it is you really mean that you're wanting your students to as it is designing the environments. So I'm not saying that we're actually just starting doing an English course. And we are going to be using peer-to-peer technology. We're going to use all kinds of different technologies. I think sometimes when I show the tutoring technology, people think that's all I'm talking about. It's not. I mean, there are lots of different kinds of learning experiences students have in an OLI course. The important thing about OLI is not the specific tutoring or learning technology. It is the design process and the design team, and bringing the acknowledgement that you bring together the multiple domain experts with the learning researchers, with the software engineers, to really take on the challenge of, can we create an environment that would support learners to get to where we want them to go after engaging in the experience? And what exactly the technology does, what the widgets are, that's not pre-specified. That's why we have our own software engineers. And we don't always guess right. You know, like we design these cool things, and then we have students do them, and it's like, did it work? Well, not really. Well, let's take it back to the design board. Did that answer your question? No. Do you want to try? Do you want to try again?
Yeah. I mean, I'm thinking, how would you know if they learned it? In other words, I don't.
How do you know now?
Judgment.
Okay, but so one thing that I would do with you, this would be fun. We should actually, you and I should get together and try and design something. What do you teach?
History of education.
History of education. I would love to take an afternoon with you and see if we can create something that you would say, oh, this might actually support my students to get somewhere I want them to go. That would be really fun, because it's really about, you know, because there's a way you know. It's not explicit to you. But you look at, and what I'd probably have you do is I'd have you bring me a bunch of your student work and say, okay, so this is a task you gave them on a midterm or a final or a writing project or something. Bring that in. Let me look at all of those things. And now divide these up. Show me these are the students that get it, that are there, that are demonstrating that judgment you want to see. And these are the students that don't. Okay, now let's see if we can see what's in there.
What's the it? I mean, it's not like there's a single it.
No, there could be a...
Is completely wrong-headed but totally interesting. Is that it? I don't know.
Great, and yeah, that would be the first step. Yeah.
You know, this one is really synthesizes everything. A computer module would have checked it off all the boxes and said you did it, and it's just completely uninteresting, and you added nothing to it of your own. It's like, where does that come from? I mean, I don't know how you're getting some student feedback to say, oh, you're getting it now, because the it is amorphous, and so determining what the it is.
So you give everybody an A or not? Is that how you do it?
No. Use the whole scale, unlike a lot of people. Yeah.
And can you choose things that belong in the middle of the scale somehow?
Do I
Sort of
choose?
it. You have judgments that they're sort of it.
Yeah.
But the way you do that is unaccountable.
Yeah. Yeah, it's judgment. In other words, it's not like there's an algorithm that's going to come up with it, because there are too many possibilities coming together, and you're looking for somebody who can make rhetorically effective argument based on evidence that has some connection to the reading and has some value added from the student, and whose outcome is not for me to predict, and I'm often surprised. Good papers look very different from each other.
Can I say this in another way? I mean, David, I would suggest you're absolutely right. I would submit that Candace's project is a threat to discretion. She takes away your discretionary judgment.
And eliminates judgment.
No.
Okay, so...
Judgment.
Okay, so let me also say that I also have to say something, which is I'm not trying to replace your judgment or replace what you do. I'm trying to look at what part, when we're trying to create an educational experience for our students, there are multiple resources that we can bring to bear. We can bring the students' interaction with some kind of computerized environment, the students' interaction with their peers, and the most precious interaction, which is the students' interaction with me, with the expert, with the faculty member. And right now, we are loading up most of that interaction on one of the resources, which oftentimes doesn't allow us really to get the best benefit out of that resource. And what I'm looking at is, can we use these affordances of the technology, of peers, of other things, to offload some of the stuff that rightfully can be offloaded to those other resources, so that most precious instructional experience can be really elevated to be used most effectively. And that's really the question. So I don't want people to think that what I'm trying to say is, let's take what you're doing and figure out how to move it online so that we can just blow it up. Not at all. I'm really looking at how do we use what we know about learning, the affordances of the technology, and your expertise to design an experience that will augment and enhance the students' learning. And also give us real insight into how students learn so that we can keep making better and better and better tools like that.
Hi, John Mitchell. I think we were on a panel together.
Yes, we were. How are you, John?
I have a different kind of question.
Okay.
So I'm trying to think about how to help people here on campus develop online teaching and learning resources. I tend to organize things in kind of a two-dimensional kind of space. And one dimension is how many people are really interested in the topic. So there are some topics that are fundamental, part of the pre-med sequence. Many, many people study that. Some other things are kind of esoteric, and there are only 3 people in the world who really care. And then the other dimension is how fast is that topic or the way we understand how to teach it changing? So on one extreme is something like calculus. I don't know how many hundreds of thousands of people are going to learn calculus over some time, but it's probably worth, renting a movie studio in Hollywood and making a really good calculus class. On the other hand, I've taught computer security. What I want to teach this quarter is different from what was in the news last quarter. And it's probably very different from what was there last year. There's still a reasonable number of people interested, but field changes. So if it takes me a year to put something together, it's kind of no longer of interest. So I'm curious, for all the methods that you've talked about and considered, how do you treat something that's stable and long-term differently from something that's moving quickly? You only have a little bit of time to do something. You want to kind of get something out in a kind of timely way.
Okay, so I should say that in our project, mostly where we focus, because I should also say that my project is 100% grant supported. So that in some ways restricts the things we get to explore. So as you probably know when you're reading the news, most of where the grants, the funders these days are really interested is in the introductory, high demand gatekeeper courses. So that's mostly where we focused our attention. But the thing about those courses that even have content that changes rapidly, like some that you might not even like, biology actually changes pretty quickly. There are still, the question is how much of it is changing, how fast. So if there's still, especially in an introductory course, a core thing, and then you want to keep shifting on top of that, then that's pretty easy to do, to sort of pull in and pull out. So part of it is to look at what's the core stuff that isn't going to change as rapidly, and then how do you build on that with the ever-changing parts. Did that? I mean, it's and you're. Yeah, because some of it, too, is that, I won't, but we'll talk more about that matrix, yeah.
So my name's Ben Gebermedin. I'm a sociology grad student at Cal.
Hey! Sorry, that's where I did my undergraduate.
I saw the sign. It's a problem. So I have a whole lot of thoughts, and I'm going to try to deliver a question that you might be able to answer.
Okay, that's okay. I like hardballs. Everyone's being so softball.
I'm really interested in the earlier discussion, and for me, I frame it as the sort of structure of expertise. And back to your idea of big data, right? So you're saying that your big innovation here is that you're going to create a lot of data, and that data is going to probably need a bunch of experts to manage, right? And so somehow we've got this new thing, this data, and then all these experts that are going to manage it, and then a bunch of other experts from different fields with entirely different epistemological perspectives trying to figure out what to do with it, right? And so you've created in simplifying the process of learning, you've created a far more complex environment in which all these people are trying to contest and define their terrains. And so that's the big thing I'm thinking about. And my question has to do with, if the data is your innovation, And you're talking about these innovations on mostly traditional university campuses with faculties that pre-exist your intervention, right? You're only going to be able to collect so much data in so many areas because there's going to be pushback. You've got these private entities that are collecting tons of data. I think about for-profit universities that are upstarts with no faculty that they have to deal with. They can collect scores and scores of data on any topic they choose with no pushback because there's no resistance. So wouldn't their processes and their technologies, which we don't get to see in public presentations nearly as much, wouldn't they kind of like just blow by yours pretty quickly? And wouldn't that be where we'd expect, in terms of innovative learning technologies, the cutting edge to be?
Okay, so you asked several questions there, but I'm going to answer your last one first because it's a choice. And I think that everyone is saying that the sort of, not for Stanford. I mean, higher education, not-for-profit higher education is not a uniform sector. You know, there are a large number of our brethren who are confronting that problem, that attainment and cost problem. Berkeley's probably closer to that problem than Stanford is. Carnegie Mellon and Stanford, for the most part, occupy this kind of elite alternate universe where we still have lots of people that want to come to our institutions, are willing to pay the price tag. We have big endowments. Well, Stanford does, Carnegie Mellon doesn't. Big endowments that can support it, or we're really good at getting research money. So the need to use technology to increase productivity is not something that we have really driven towards. It's really using technology more to enhance the learning experiences, as I described. And now you're talking about, you know, these, what people see as these disruptors that are coming in that will use these kinds of approaches and may be able to innovate much more quickly than we can because they have a market motivation to do so. And I think this is the question that I think is confronting not just large publics, but elite universities too, is how do we want the future to play out with the use of this technology? And are we going to sort of let the either for-profit players or the publishers or others external to our institution take a core part of our business process, if you will, and own that? Or are we going to, and I think this is actually the role for the elite institutions, because we're not under this pressure to do it quickly and do it now so that we can solve the problem. So we have a little bit of luxury of both position and time and expertise that we, and I think it's our responsibility to get out in front of this thing and lead it and not have it hit us sideways. And that's what I'm trying to get Carnegie Mellon to do, and I'd love it if Stanford would do that too. How much time? You know, how much lead time? Yeah, not a lot. I mean, no, you know, in terms of like for what to happen, for Stanford to be at risk, you've got a lot of time. That's not going to happen. I mean, that shouldn't be what's driving Stanford to explore this. But to take a sort of a positional leadership role, I think that should happen soon. Yeah.
Yeah, I just want to follow maybe up on David's point. And this is you've been working very hard, Candace, and so this is maybe a more comment than a question. But I'm getting, as a student of your presentation, with lots of hints, the learning model, the theory of learning seems to be very much revolving around efficiency. That the goal of learning in this context is the improvement of the efficiency of learning. And the adjustments that are made and the introduction of the technology and the widgets that we choose have as its goal a greater efficiency of learning. And so we need to think about where the ultimate end of that is. Can we get a system so efficient that it can do the course in half the time, in a quarter of the time, in a tenth of the time, and so that we can not do ourselves out of a job so much, but that we have to think about the consequences and the kind of goals that this suggests. So
can I shift your word from efficiency to productivity? Because efficiency, I know no one likes the P word either, but what I like better about the P word than the E word is that there's an element of quality.
I'd love to take that up.
Okay.
There's another side of productivity I want to address.
Okay, and so yes, to some extent, I am looking at, can we use the information technology to accelerate, make more productive, more efficient the function of teaching and learning? But then the question is, what do you do with the productivity gain? And what you do with the productivity gain, how you answer that question is going to be very different in different sectors. So the OLI statistics course, as I think I mentioned, was used in 60 different institutions last semester, from Santa Ana Community College to Bryn Mawr. And I don't know if you think of those as polar extremes, but I was kind of going for the, elite liberal arts college. The way they use it at the elite liberal arts colleges is very different. So they have the statistics course. It's a service course. It's not for statistics majors. They have majors in all different disciplines. And so they use the OLI statistics course in accelerated mode. So they complete all those outcomes in the first 8 weeks. And then but they didn't just say to the students, okay, you got statistics, bye. They then took the remaining 7 weeks and said, okay, do something meaningful in your domain with this knowledge. Pick some question, some data analysis problem that is meaningful to you, and you define it, you go off and learn the tools, and you come up with a project and do it. And they spent the next 7 weeks doing these really rich data analysis projects that then they had them present in posters in a little mini conference at the end of the semester, and all the students peer-reviewed each other's posters as well as having the faculty review them. And they could only do that because they were able to, all that foundational skill knowledge, they could build that up really quickly in the first 8 weeks. And then they also had access to that environment so that as they were doing the projects and were bumping up against something and going, oh, I don't think I really remember when I should do a t-test so well, I know where to go back instantly and get that.
That's a brilliant response to that. I still think it's efficiency in a way that the latter part of the course is more productive. So I was going to introduce the idea of things like Fold It and Galaxy Zoo and areas where there's online learning where the students are producing or contributing in the process of learning. So the Washington UW Center for Gaming and Learning.
Yep.
So that to me would be the beginning of that, because you had that lovely John Dewey learning by doing phrase in one of your slides, and it does suggest we could be doing something more productive than just greater efficiency in the acquisition of these units.
I agree completely. And that's, I mean, I probably can't say this enough. I'm not saying that to me, OLI is not just the technology. It is an approach. And it is really looking at how, it's a research question. It's how do we use the technology and what we're learning about human learning to think about how do we construct fundamentally different kinds of learning experiences that both accelerate learning and also enhance and create much richer.
Learning about learning is really the efficiency question. You're just learning how to make people learn more efficiently. And I think that's not the whole of learning.
Yeah, it's not. And I guess I don't agree with you. Because I'm trying to explore also what is learning. That's the whole research piece.
Hi, Jonathan Osborne, School of Education. Thanks for some very interesting answers. I want to pursue that one a little bit more, because I was sitting here, like John, thinking that really what we're hearing is a very technocratic solution to the problems of education. And in some senses, you've partially answered my concerns, but what is missing a lot from this platform is that sense, I think, that goes with lots of good learning experiences. I mean, yes, I would agree this is going to be a substitute for a lot of bad learning experiences. I would much rather have done this than some of the kinds of chemistry lessons I sat through. From that point of view, I would have learned a lot more. But it's not a substitute for the good learning experiences I've had. And the good learning experiences I've had have been fundamentally social and transformational in that sense. And I can't see it doing that. Now, I'm concerned that people, and I won't put you in this category because I think you've been nuanced enough about in some of your answers, but I am concerned that people see this as a substitute, full stop, for that kind of learning. And really, I think what needs to come is a recognition of the limitations of what's going on at the moment. And I'd be interested to know what you think are the limitations.
Okay. So first off, I agree with you completely. So, as I said, I'm not trying to say let's replace what happens, the very rich learning, transformative experiences that people have at our institutions. I'm not trying to replace those with an online environment. I'm looking at how do we use the affordances of the technology to make those experiences actually more enhanced. I'll give you a short example. When we did our introductory logic course, logic is taught at Carnegie Mellon still in like 40-person, 35, 40-person classes with a full professor. And before we did the OLI course, the faculty members spent a good part of that 35, 40, those small classes going over how to do a proof. Mechanics, lots of foundational skills, and the students didn't get the benefit of having this world-famous logician teaching them. So we did the OLI course, and now the students learn all of that before they come to class. And the kinds of conversations, the kinds of transformative experiences they can have in the class are much more frequent because they're not spending that very precious resource doing something that the computer could actually do. So, but I agree with you completely that we don't want to, I disagree with everyone who says we're creating these online environments to essentially create a Stanford education that people now in the world have access to. That is blatantly not what we're doing. And so I don't know if that addressed your, really it's not, I think it's, maybe I need to figure out how to get folks over this conceptual hump. Okay.
They're being sold by people as that kind of solution for education problems, and they are not.
They're not. They're not.
People need to be absolutely clear about what they do well, like that example you just given, and what they do not do well, which I think is foster that kind of social interaction between people, which stimulates interest and engagement. I mean, you still, what creates passion for a subject is the person standing in front of you getting excited about it. No way that machine's going to do that.
Absolutely. So, I mean, that's some of what creates passion. Another thing that creates passion is a blinding flash of insight where you know, that experience where you go, oh, I see this thing in a completely different way. That creates passion, too. A sense of, I can do this can help create passion. For students that are sitting in classes, and I know this doesn't happen much at Stanford, but a lot of other institutions I talk to, students are nowhere near getting the benefit of the passion of the faculty member because they just are sitting there feeling confused and overwhelmed, and I don't belong here because I don't know what the heck is going on. And so if you can get that student to have a sense of, I do belong here, I can do this, I do know what's going on, then when they're sitting there in that classroom, there's a much better chance that that passion will ignite in them what we're hoping it will ignite in them. So that's why I keep talking about we're not replacing. We're really looking at what is the best way to use these technologies to enhance the experience, but also to solve a real-world problem that Stanford maybe right now isn't experiencing, but that higher education writ large is. And I'm not trying to solve that problem, by the way, by saying, okay, let's have a whole bunch of students take the OLI course instead of their statistics course at community college. I'm saying let's have the students at community college take the OLI course in combination with their traditional course so they can get a lot of that taken care of so they can maybe have a chance of having that transformative experience in their classroom.
So I just wanted to make a comment. I think that part of what you're saying is that we need a research agenda that goes way beyond the interaction with the technology, that actually addresses how these courses play out in people's lives, how they play out in the classroom. So if you had a strategy that used discourse analysis, for example, and did comparative work and longitudinal studies and look at affect and motivation, we might learn more about the kinds of problems that people are concerned about.
Yes, exactly. Thank you. That was beautiful, because that is really what I want. As I said, OLI has been really informed by the depth of research expertise at Carnegie Mellon. But that is a slice of looking at learning. There is a lot of research being done in the world that looks at all different parts of learning. And so my vision is to get multiple perspectives about learning so that we're not having those arguments anymore, but really looking at how do you synthesize and apply these various methodologies and these various theories to support a lot more students with a much greater variability of background knowledge and skills and goals to be able to have a positive higher education.
We have time for one more question or comment. Let me suggest also that in addition to the research agenda that you're talking about, there's a normative research agenda here too, which is I have a strong sense that where we're at this moment in the history of education and modernity obliges us to say, well, which parts of what we're doing are rationalizable in ways that these kinds of capacities are going to enable us to do? And what are the other aspects of schooling? We can't just lean back on Dewey and Thoreau anymore. Basically, we're going to have to parse the different components of value in ways that we haven't been obliged to do, at least as post-secondary educators, in the way that we have to now.
Candace,
it's a big, exciting research agenda.
Totally agree. Your talk comes after a week of William Bowen here giving the Tanner lectures with panels of a variety of kinds. Anybody that went through everything spent about 15 hours engaging in that discourse. It was fascinating. And one of his highlights, certainly he focused on the cost disease of higher education as about time to degree, and that the elites aren't going to have to worry about it, but everyone else will. And more than a few people asked Delbanco, for example, if His Hennessy says this is the campus tsunami, what will the tsunami destroy? And there was quite a lot of discussion around how what will likely be destroyed are middle-tier institutions, faculty within them, because the argument being courses like these will be used for productivity gains in many of those institutions that cannot afford the spiraling costs that they can't contain because the passionate professor is expensive and irreplicable. And the public is putting way too much pressure on cost reduction. Stanford can ignore it, others cannot. So Bowen kept highlighting, and I love this phrase, that we really have to preserve the value of minds rubbing minds more than anything else in education. And so I guess one agenda would be how, in the context of this work going forward, can OLI and its derivatives bring minds rubbing minds up to the very visible surface rather than bury it in the teams that are making the courses?
I'd love to. I mean, and the thing is right now there's a very, very, very small percentage of the population that gets to experience minds rubbing minds, and I worry that I mean, Bill Bowen has his worries. I have my worries. One of my worries is, as Brenneman talks about, the bifurcation of the higher education system, where we'll have a few privileged institutions that still get to do education with minds rubbing minds and have people, experience alternative perspectives and grow and all of that kind of stuff. And then we'll have the mass education system, which will be largely targeted at workforce development. And that's not a future that looks happy to me. Unless we can make the mass education have a lot more of the experience of the minds rubbing minds. And I think that to be able to do that kind of education at scale, we have to find productivity means. I don't think there's and in terms of the question about does this mean that the role of a faculty member is going to be diminished? That's another concern. If your OLI course is basically teaching the student statistics, then what do? Am I just a TA to your OLI course? And I actually think that these kinds of environments, when they're really well developed and used, will actually enhance the role of the faculty member, not diminish it. Because it's a lot easier, and maybe this won't sound good to you, I think it's a lot easier if you've taught the course 3 or 4 times, you always know, week 7 I give a lecture on this. You can kind of just do that. It doesn't really leverage your expertise to think of it afresh all the time. But if you're getting information, if you're saying, okay, this is where I'm trying to get my students, and you're getting information about where your students are, and every class you have to think about how am I going to design an experience that will leverage my expertise and move my students from where they are to where I want them to go, that's actually a much higher skilled task.
All right, time out.
Okay,
Candace,
sorry.
thank you so much for contributing to our thinking here.